In this week's problem, Roman and Caesar are going for a bike ride. Caesar is slower, so Roman gives him a head start, and our job is to find out how many miles each will have traveled when Roman catches up with Caesar. Well, of course, this is a big week because it's our annual visit to rate times time is equal to distance. And those students who have had some algebra may have set up this equation, or perhaps this equation. And the solutions to the equations are shown, but neither one is the answer to this week's problem. However, if you substitute those answers in for the variable t in each equation, those students should have been able to find this week's answer. But for those of us that haven't had algebra, let's reenact the problem. Here's Roman and Caesar, and no wonder Caesar's slower. His bike has training wheels. Well, let's set it up. After an hour, Roman has not begun, and Caesar's gone his 15 miles. After 2 hours, Caesar's at 30 miles, and Roman is still sitting there. After 3 hours, Caesar's at 45 miles, and Roman has fallen asleep. But then, after 20 minutes, Roman wakes up. During that 20 minutes, which is a third of an hour, Caesar travels a third of his hourly distance, and a third of 15 is 5. Now Roman is ready to go. So an hour after that, Caesar's up to 65 miles, and Roman has gone his first 25 miles. Another hour, and they're at 80 miles and 50 miles. Yet another hour, 95 miles and 75 miles. And after 7 hours and 20 minutes, Caesar's at 110 miles, Roman's at 100 miles. Raise your hand if you know where this is going. And at 8 hours and 20 minutes, they've each traveled 125 miles. 125, the answer to this week's problem of the week.